I'm Anil Kumar, and in this video we will try to understand conditions for rational functions without vertical asymptotes. So the question for you is, describe the conditions that will produce a rational function with a graph that has no vertical asymptote. So now we are looking for a rational function which does not have any vertical asymptote. So you have to describe the conditions for that. Correct? So you can pause the video, answer the question. We already had a couple of videos which will give you clear idea of how to summarize our learnings. So we are going to summarize these learning. So what we are going to do here is, we are going to write conditions for no vertical asymptotes. This is what we are going to write. So okay, I will sketch few graphs and I think they will help you to write down the answer. Okay, so one of the graph is kind of like this. If I sketch a graph like this with a hole here, now you can see there is no vertical asymptote here. Correct? It represents a rational function. Now if I sketch a function like this, here also you will see there is no vertical asymptote here. Do you get the point? So here also there is no vertical asymptote. So in such conditions we observe that we will not have vertical asymptotes. Now what can you conclude? We need to describe all the conditions that will produce a rational function with a graph that has no vertical asymptote. That means like this. So in this particular condition, let us say we have a line here with y-intercept at 1 and the slope as, let us say, 1. So we could write, and this discontinuity, let the equation be y equals to x plus 1, correct? Now in this equation, let us say the discontinuity is at 2, which is the whole. That really means that the rational function should be equal to, there's a common factor in numerator and denominator, which is x minus 2. Do you see that? X minus 2. That is a common factor, and the numerator has the value x plus 1. Correct? So there is no vertical asymptote if the 0 of the denominator is also the 0 of numerator. So that is first condition. So one condition is if, so let us say our rational function is, let us say r of x is p of x over q of x. Then if zeros of denominator, which is q of x, is also 0 of p of x. So that means there is one common factor, right? So all those factors will cancel out, yielding a whole, correct? That is one condition. In this particular case, there is no vertical asymptote since the function, so we are talking about a rational function. In this particular case, the denominator is never 0 since q of x, which is the denominator, has no zeros. Correct? That is the case. For example, we could write a rational function in this case as equals to 1 over, let us say, x squared plus 1. In that case, this value is going to be 1. Now x squared plus 1 is never a 0. Correct? So in this case, there will never be a vertical asymptote. So these are the two conditions when a function's graph will not have any vertical asymptote. That is kind of important, right? Now here's a question for you. If I have equation like this, 1 over I should say 1 plus x, let me write down, over 1 plus x whole square. Will this have a vertical asymptote? This will have. Since there is 1 0 here, which is not a 0 in the numerator, we have denominator has double 0 at minus 1. Do you see? The numerator has only 1. So one of them will cancel out, the other one remains. So the important point is, if zeros of denominator is also zeros of numerator. So all zeros should cancel out. If any one of them remains, then that will result into vertical asymptote. So that is how you can summarize the conditions for a rational function without a vertical asymptote. I hope that helps. Thank you.